In part 1 of our lesson on the trig form of complex numbers, we will derive the trig form of complex numbers. Let's start off by plotting some complex numbers in the complex coordinate plane. Now the horizontal axis is called the real axis, and the vertical axis is called the imaginary axis. Now, in order to plot z1, which is -4 plus I, we know that the real part is -4, so we would go -4 on the real axis. The imaginary part is +1, it's the coefficient of the I, so we go +1 on the imaginary axis. And we draw the vector that starts at the origin and goes out to that point. So this is z1. z2 is equal to 2 plus 3i, so we go 2 on the real axis, and we go 3 on the imaginary axis. We draw the vector from the origin out to that point, and this is z2. We are also going to plot z1 plus z2. Now, if we go ahead and do that arithmetic, we add up the real parts, so -4 plus 2 is -2. I plus 3i would be 4i. So we go to -2 on the real axis, +4 on the imaginary axis, and we draw the vector from the origin to that point, and that is z1 plus z2. Now also think about it this way. If we were to draw the parallelogram from the two initial vectors, we know opposite side z2, we would have to draw a side that is parallel and equal in length, and that would be this side over here. Opposite of z1, we would draw a side that is parallel and equal in length. So you can see that adding the two complex numbers is just like adding vectors in that we could make the parallelogram, and the resultant, which is the sum of the two vectors, is the diagonal. Now let's consider complex number z, which we have graphed here. Z is equal to x plus yi, so we know that means this horizontal distance here is x, and this vertical distance here is y. Now if we think of this as being an angle in standard position, we know this is theta and this is r, so the cosine of theta would equal x over r, which means if we solve this for x, we would get r cosine theta is equal to x. Sine of theta is equal to y over r. Cross multiplying, we get r sine of theta is equal to y. Now, if we take those two equations, x is r cosine theta and y is r sine theta, and we substitute for x and y in the rectangular form of z. So let's make a note of that. This is the rectangular form for complex number z. We are going to take r cosine of theta and substitute it in for the x, and take r sine of theta and substitute it in for the y. Then z is going to now equal r cosine theta plus r sine of theta times I. Now we notice that each of these terms has an r, so let's factor that out. And we have r times the cosine of theta plus I sine of theta. For clarity, I want to put the I in front of the sine of theta so you don't accidentally think that the I is part of the argument of the sine function. Now we have a shorthand notation for this where we say z is equal to r cis theta. And the r comes right from this r. The c is from the cosine. The I is from this I. The s is from the sine. And the theta, obviously, is the theta that's in each of those trig functions. And this is called the trig form. So this is the same complex number, z, that we had earlier in rectangular form. So z is equal to x plus yi. That's the rectangular form of this complex number. Or, equivalently, we can say z is equal to r cis theta in the trig form. That also gives us this complex number. It's two different ways of getting there. With the rectangular form, x plus yi, it says go over by x, up by y, and then draw the resultant. In the trig form, it says you're at an angle of theta and you go out a radius of r and you end up at the same point. Now let's make a summary box here for the trig form of complex numbers. We just learned that the trig form is that z is equal to r cis theta. And remember, the long form of that is r times cosine theta plus I sine theta. The rectangular form is z is equal to x plus y times I. Now we can go back and forth between trig form and rectangular form by using conversion factors here. Remember, we got to trig form by substituting in for the x r cosine theta, and substituting in for y r sine theta. So if we know r and theta, we can get x and y in the rectangular form. Or if we know x and y in the rectangular form, we can get to the trig form because r is the same as it's always been, the square root of x squared plus y squared, and tangent of theta is equal to y over x. So these are the sets of conversion factors we can use to go back and forth between trig form and rectangular form.